All right, so this is our Razor E325, same thing as the E300, and we're going to be doing a little hybrid conversion on here. So we got the standard electric motor, stock setup, new batteries. Gets about 3 to 4 miles of range, only hits max of 13.5 miles an hour. That won't do. So we're going to be slapping this Ryobi 26cc two-stroke motor on it, but we're also going to leave the electric motor on it so we can have dual power. You can use the gas power or electric, whatever you want. And we're going to be doing that as cheap and as easy as possible. So we've already got the scooter torn down, and then we've got the motor torn down also. The hardest part is going to be mounting another sprocket to the wheel. So basically what I've done is I got a cheap little number 25 sprocket off of Amazon, and then this is the drum for the brakes, and it basically just threads on to the wheel itself. I'll show you the other side. This is the original sprocket for the electric motor, and it's on a freewheel setup, which is going to work great so we can use the gas engine and not be dragging along the electric motor, possibly backfeeding into the controller. So this is some rudimentary mounting and measuring I did. Basically just kind of opened up the holes a little bit. I bolted it down to the drum for the brakes, did some measuring with some calipers, and the most run out we have on this is about 0.23 millimeter of run out. That's about the width of a human hair, so that is pretty dead centered, and that shouldn't give us any issues for this setup. So now what we're going to go ahead and do is take our cheap little Harbor Freight welder, apply some welds to the inside of that sprocket to the drum, and then the way this threads on is just normal righty-tighty, lefty-loosey. It's going to be orientated in this direction. When the chain is pulling on the sprocket, it's going to want to unthread off of the wheel. So both of these components are steel, so we're going to thread this on as tight as we can, and then just lay a nice little bead around the hub and then the drum, and that should give us a pretty good result without it wanting to unthread itself. So we're going to go ahead and do that. Another issue we had to address is the engine has a centrifugal clutch basically threaded right onto the crankshaft, and then the clutch housing is a part of the pull start mechanism and the plastic shroud for the engine itself. So as you can see, it'd be kind of hard to mount a conventional 4-bolt clutch to this engine. So what we went ahead and did is we're going to utilize the stock setup. Just kind of cut down the shroud of this cover, measured our shaft where normally the square shaft would go into the clutch for the trimmer, and that is 12 millimeters in diameter. Amazon, I think this was $8, just a custom looking sprocket, number 25 chain, 12 tooth, and as you can see, it fits like a dream. So what we're going to do is put that on there. We're not going to weld it just yet. We're going to line it up once the engine's mounted, but has 2 little set screws. We're going to set that on there, crank it down if we can, maybe create a little flat for the set screw to bite onto a little better, and then maybe apply a nice little tack weld on there, and then that should hold up pretty well. All right, now we've got it all welded up together. We have welded the sprocket to the other side of this brake drum, and then we thread it onto the wheel, and then we put some tack welds all around just to encourage it not to unthread itself when the chain applies tension. So this assembly is done. Don't judge my welds. I am a machinist by trade, not a welder. So this should at least teach y'all you don't need to be a professional to make a weld that works. The best part is you're not going to see it either. We have the wheel assembly back onto the frame, doing some test spinning, and we can see where it's going to be making contact and we will have some fitment issues. So it's lined up with the hole in the frame where it bolts through, and then the armature bolt, or nut should I say, is making contact with the sprocket, so that will have to be addressed. And then the brake housing is making contact with the sprocket as well on the back side. So we will have to remove some material from the back side and then address that nut issue as well. So some slight modifying, but not a big deal. Everything seems to line up pretty good though. To try to address the brake housing from hitting sprocket, when you take this housing off, you're going to find not the shiny part, but the black dowel spacer. You're going to find that inside, basically spacing out the housing to the drum bearing as well. So basically I took that off. I found this old spacer in my toolbox. It was very close, so hammered it in. As you can see, it gives it a little bit of extra room for spacing. And now that may just give us enough extra clearance. So we'll see if we have to massage anything else to fit, and then we're going to try the test assembly again. We have the wheel back on the frame. After clearancing a few things, it does get pretty tight. We may have to clearance a little more once we get the chain and the engine mounted, but it may work. We may need to trim a little bit more, but for the most part, it does seem to be looking pretty good. The only thing I did notice is it could be the frame itself from how it came from factory, but both sprockets actually, they have a little bit of side play to them, but not terrible. It's pretty straight for the most part. Even the factory chain, it does have some side to side wobble. It could just be the frame not being trued up or the rim being slightly off-centered. Either way, it's not too bad and nothing that a little chain tensioner can't remedy and fix. So we're going to proceed. Now we cranked it up, we're going to do a wheel test. So that's our good first test there. Yeah, as you can see, the wheel itself has wobble. That is not anything that's been modified, straight from factory. So I'm going to see what we can work with a chain tensioner and make this work. Next order of business is mounting the engine, or making some type of engine mount motor plate. Being a weed eater engine, it never had intended use to be mounted on the bottom to something. It was just supposed to be on a handheld operating system. So basically what I did was I removed the fuel tank, which was secured with these 3 bolts, and then kind of hacked up some decently thick, maybe 1/8 inch thick steel plates. I got the plate for like $5 or something like that from Tractor Supply. Drilled some holes, kind of cut it to fit. This is a rough template of what I'm going to be using. I'm gonna obviously clean it up, weld the joints tomorrow. But this will allow us to have a nice flat spot to mount it onto the frame, and then 2 bolts to bolt it there. 3 points of contact. We may have to add another anchoring point somewhere, but that will be determined once it's mounted onto the frame itself. May have to tie in to the beefy exhaust bolt possibly. Other than that, I don't really see many other options or places to bolt it onto and bolt some type of support, but this may do just fine. So we're gonna mount it up and see. Okay, so we basically finished making the engine mount, or pedestal, whatever you want to call it, for this engine, and we put it back together. So I added to that first portion I made, and added a piece of 1¼ inch square tubing to the bottom. It's not welded. I want to make sure this thing is serviceable as much as possible, or it leaves me room for adjustments if I need to. So basically, just drilled some holes, a relief hole for the bolt that connects to the engine block itself. Like I said, not a great welder, but I welded a bolt, the head of it to the bottom and inside of the square tubing, so that way it makes it a little bit easier just to mount and unmount this engine. So I can just undo these bolts and these nuts, and then this comes off, and then of course have the 3 bolts that hold the plate to the engine itself. So it's completely serviceable. It's not permanent. So basically we've got that going on, and then my idea here is to take the rest of this 1.25 inch square tubing, maybe weld it to the frame rails up top like that somehow, and then take this guy, place it down on there, weld the square tubing together, and then it should give us a pretty good result. I'm gonna have to shift this over as much as I can, so gonna be in the way a little bit, but it's a DIY project, so I'll just have to kind of tack weld it and then line up the chain, make sure it's going to not pop off and it's aligned as best as possible. And then as far as the sprocket on the clutch drum itself, I went ahead and just kind of welded it on there. If the clutch ever does burn up, worst case is we throw this on a bandsaw, we cut the snout off of that clutch drum, and then we have to replace the clutch drum anyway, so it's not a big deal. I figured this would be the best choice as far as minimizing slip from the drum to the sprocket itself. So we'll try that. Yeah, so now we just got to get to test fitting and welding. We started welding up our 1.25 inch steel tubing frame rails, and we just got a couple tack welds on there for now, just so we can make sure it's going to function properly, and if we needed, we could easily remove it and start over. So we've got these tacked on. Just gonna take the engine, square up the box tubing, and just kind of make sure roughly it's going to be something we can work with. It does look like we can work with it. So what we're going to do is start cutting the chain down to size, and then we're going to make sure there's going to be no interference in this area here with the steel tubing, and make sure it's not going to contact. So we're going to start cutting the chain down, and then if everything looks okay, something like we can work with, then we're going to do a full weld on the steel tubing. We've got the engine eyeballed as best we can, chain cut down and mounted, and then we have it tack welded just to the makeshift frame now. Just tack welded, so in case we have to make any changes, it'll be very easy to do. We don't have to go cutting like crazy. So basically what we have is we have the baseline chain tension. We still have a little bit of slack, and that's okay. We're going to add a chain tensioner just to account for any slack that may occur, and then when you get on the gas, some contraction of the chain and tensioning. So you don't want to have it too tight, too loose, but that is a good amount for a chain tensioner. So now what we're going to do is test it out with the electric motor and make sure that it is fairly aligned. And that seems to work beautifully. So with the electric motor, that is the equivalent about like 15 miles an hour. With the chain, that's without a chain tensioner too. So with the chain tensioner, this should work fantastic. So what we're gonna do is go ahead and finish welding up the 1/4 inch, tube steel to the frame, and then welding the engine cradle base plate to the frame. So then we can start testing it out. Another thing also, when you're welding on a frame of any kind of vehicle that has electronics on it, ideally you would like to disconnect the battery terminals, but in this case they are soldered on, so that's not a possibility. So what we went ahead and did is just unplug every single thing that we can, mainly especially like the power wire. So there's no connection from the frame itself, from the welder to the speed controller. That could easily fry electronics, and it's a good habit to do. You got it kind of halfway set up here for a little test. Backtracking a little bit, went ahead and drilled out the welds on the sprocket, dremeled it out, took that 12 tooth off, and then went over to Amazon, found a 9-tooth sprocket to try to gear it down 25% more to give it a little more RPM and get into that power band a little bit better. Issue is for the anything lower than a 12 tooth, they don't come in a 12 millimeter bore, which our shaft is running. So we're gonna have to try to get a little creative. Got it set up on this drill press here. We're just gonna step it up from the 8 mil drill to center it, and then bump it up to like 8.5, 9, slowly chip away at the inner wall. And that undercut for the chain relief, that is actually 12 millimeters. So we're not gonna be able to fully drill all the way from the back to the face. So we're gonna have to try to just go all the way up to the undercut, the 12 millimeter bore, and then not break through that wall. So we're gonna go for a little test drive. I actually already did test this out. I got to 23 miles an hour, way better than the last speed run I did with the old sprocket. Only got it up to about 18 mile an hour maximum going downhill. The average just cruising on a flat level road was about 14. So we bumped it up about 9 mile an hour just by re-gearing it. It revs all the way out, gets to its top power band, top RPM. It does everything you could ask for it. So I'm gonna go do a little ride and show you guys.